Hello, we are Team 25032, and we have been tasked with designing the Solar Performance Estimation Kit, referred to as the Spek. My name is Jack Hughes. I'm one of the software engineers and the team lead.
My name is Natalie Barnhouse. I'm the procurement lead and one of the mechanical engineers.
I'm Kari Cordes. I'm another software engineer on the team.
I'm Spek Longoria. I'm the last software engineer on the team.
I'm Matthew. I'm one of the electrical engineers on the team.
I'm Hannah Spallas, and I'm another electrical engineer on the team.
And I'm Jacob. I'm the last mechanical engineer on the team.
Our objective is to measure the solar energy production in any location to determine the number of solar panels required to reach a net $0 electricity bill. This will help homeowners to decide whether they want to make a large financial investment in installing solar panels for their home.
Our approach was to first draw up a couple of designs. From these, we chose the final design that we continued with to this day, a portable kit with a handle and beanbags to weigh it down securely to the roof. We prototyped this design with 3D printed parts, then did some wind and heat analysis. Modeling it in SolidWorks allowed us to see how all the electronic parts fit in, which led us to making the box bigger as we added more required components. Doing multiple virtual and physical prototypes allowed us to visualize the final kit. Throughout this process, we researched different ways of mathematical analysis and met with industry professionals to ensure that we were sticking to our engineering standards as we were prototyping.
We had that was pretty big was making sure the system weighed under 25 pounds, so it'd be easy to carry up a ladder and be portable for the user experience in mind. Another major requirement was for the user friendliness. So we built the software so that it had the user in mind. We also wanted the system to be safe to use, so we made sure that the sharp corners are covered, and as you can see on this side, necessarily, and also that the temperature limit wouldn't exceed a certain threshold by having heat shielding material on one side reflecting the sunbeams.
The Solar Performance Estimation Kit is a portable device designed to help homeowners accurately assess their solar energy potential and cost savings before investing in solar panels. Spek collects real-time solar-powered data using a built-in panel and transmits it to a cloud-based application for easy analysis. Engineered with durable aluminum components, energy-efficient electronics, and beanbags to weigh it down, the system ensures reliable performance in various environmental conditions. By providing precise, user-specific data, Spek empowers homeowners to make informed, cost-effective decisions about adopting solar energy.
The major requirements we are verifying are broken into the three main subsystems: electrical subsystem, the mechanical subsystem, and the software subsystem, which includes the firmware. The software tests cover account creation, setting up the device, logging in, and verifying that the data is displayed on the application and the website. The electrical tests cover battery charging and battery power, while mostly the mechanical tests durability, weight, and temperature.
The final kit successfully collects and analyzes solar energy data, providing accurate power output measurements for homeowners. Through testing, we validated the system's ability to estimate potential cost savings and assess solar feasibility based on the user's data. Real-time updates to both the website and the app allow efficient and reliable access to data and analysis. With these results, we've achieved our objective of providing homeowners with precise data to make informed solar investment decisions. So here we are, we're performing our demonstration for this video. So as you can see, we have the Spek set up in the sun, and here's Jack turning it on. You can see we have this blinking LED light to indicate the status of the system, and now Jack will perform device setup using the app. First, he creates an account since he is a first-time user, which requires a username, password, first name, and email. Then he's directed to the device setup page where he enters the device ID found on the Spek. This verifies that the device exists and is not being used. Next, Jack will connect to the provisioning network hosted by the Spek, which is shown here. Then he will enter the name and password of the network he is trying to connect the Spek to. On a successful provisioning attempt, he is redirected to the login page. Now that he has an account and has the device connected to the internet, he can log in and see the data points that Spek is collecting. So on the top there, we see a graph that updates real time with data from the Spek, and then below that, the calculations would be displayed, except it requires information entered in the profile tab, which is empty right now because Jack just set up his account. Also displayed are widgets of the current power produced, the status of the Spek, and the savings estimated based on the electric bill if Jack were to click on those buttons down there.
So here we have our test to make sure that the data that we're collecting is actually accurate to our solar panel. and is actually data from our solar panel power production. To do this, I just stood in front of the solar panel and cast my shadow over it, just to kind of drop the amount of power that's producing, and as a result, we should see a dip in our graph on our website, which we'll get into soon. So this is the before data from our solar panel. There's a dip from maybe a branch, and this is the after real-time data update from our solar panel. The deliverables that we will be giving to our sponsor will be our completed system and basic use guide. So a major surprise during this project was pretty much learning how solar power worked. None of us had any experience with solar power going into this, and we all learned a lot about the nuances of this technology.
Safety was our top priority throughout this project. We as a team ensure that we always follow all safety protocols, such as wearing safety glasses when working in the EDC. We also completed the safety form assigned as a team, recording on paper our commitment to following the safety guidelines and memorizing layouts of everything we tested on the Spek to reach exits, fire extinguishers, etc. quickly in case of emergency.
We also wanted to keep sustainability at the forefront of this project. We designed it to have minimal waste and be reusable, as well as encouraging environmentally friendly living in general by giving people the peace of mind to invest in solar panels.
And finally, here is a sneak peek of our design day poster. This has our project overview, operational concept, system block diagram, methods and components, as well as goals, results, and conclusion. Some of the key things to notice are the picture of the Spek deployed on an actual roof, our PCB design, and some screenshots of our website and app.
Provided such helpful guidance every step of the way.
We would also like to thank Bob Garcia for all of his help verifying our PCB layout.
And lastly, we want to thank Darren Cole and Chuck Valance for their guidance on the mechanical system.
Thank you.